In this video, we will talk about machine learning and how machine learning helps in making predictions. In this slide, we will talk about the different components of artificial intelligence and how they are used. So in AI ecosystem, there are three main types of learning. The first one is machine learning. The second one is deep learning, and the third one is cognitive computing. So in the next slides, we'll discuss how each of these learnings are used and how they are different from one another. In this slide, we'll be talking about the first component of AI, that is machine learning. Now, the definition of machine learning is it's a subset of AI which uses the data mining techniques and other algorithms to build models. Now, to give a small example, now look at the figure on the right hand side. So there are two problem statements. The first problem statement is what is going to be the temperature at a certain place tomorrow. Now here if you see, the predicted output is a number. So whenever I'm going to predict something where the output is a number, the number could be either a discrete number or it could be a continuous number. It is called as a regression, and it can be done using the machine learning techniques. Now other examples like what is the score, what is the sales, what is going to be the profit. So these are examples in real life where the predicted output is a number. So these are known as regression problems. Now the second type of machine learning technique is a classification. Now in this example of weather, the problem statement is will it be hot or cold. So here I have only two classes. So this is called as a binary classification. So here the output is going to be a class and not a discrete or a continuous number. Now other examples in real life where we have a classification problem statement, you could think of a person who's applying for a house loan. So the bank may have some kind of an engine which can predict whether this person is eligible for a loan or not. So you have a binary class here which says the customer can get a loan or cannot get a loan. Now other examples could be you apply at a college and you get an admission or do not get an admission, whether an email is a good email or a spam email. Now classification can also be of multi-class. That means it can have more than two outputs or two classes. To give an example, there are different types of glasses. You can see glasses on cars, glasses used in houses, in spectacles, in other area of applications. Now glasses can be divided into different types based on the structure. So we can have type 1 glass, type 2 glass, type 3 glass, type 4 glass, etc. So depending upon the components, I can classify a certain glass as one of these types. So these are examples of multi-class classifications. Now when machine learning is going to predict the outcome based on the data, that engine which is used to do the prediction, that is called as a model. Now model can be defined, you can think of model as a formula where it learns the pattern of the data and it builds the formula, and whenever you supply new data to the formula, it is going to throw out the predictions, and then you take the predictions, you evaluate, and then you do some testing to find out whether this model is a good model which can be implemented or whether you want to refine that model. Now to develop these algorithms, one needs to have a good understanding of statistics, because statistics is the backbone of all these model techniques. So you have to understand statistics. Now why statistics? It is because a lot of the data that we analyze, they may have they may be of the raw format, So it needs to be corrected. It needs to be formatted in the right sequence. There could be missing data. There could be nulls. The distribution may not be proper. So the knowledge of statistics will really help you to fix these data so that the output or the predictions are something that is expected out of these algorithms. Now, maths is required because you need to transform the data. That is also one of the techniques that you might implement. So, what are the different ways in which I can transform my data from an existing form to another form? So, a little bit of mathematic knowledge really helps. And of course, you need to be a good programmer. So, whatever programming language that you choose, whether it is Python or Java or R or any other language. So you really need to have a good flair for programming. Now, apart from that, most of the programming languages, they have a rich set of libraries for machine learning. So you can use them and try it out and see whether it is working the way you want it. And a lot of times these uh, these algorithms, they have some default parameters, so you can override them and you can give your own set of values which match the data or which matches expected output, and these are known as the hyperparameter tuning. So you can use them and then get the desired results. Now, most of the time, whenever we are dealing with machine learning data and we want to do these kind of prediction models, the input data is always in form of a structured form. A structured data is one which has rows and columns, just like we have an Excel file, we have a comma separated value CSV file. So these are data where I can arrange my data in form of rows and columns, and which is very easy to read. Now, sometimes it happens that clients do give us data in different forms. And so there are two forms apart from the structured form. One is a semi-structured form, which is like a JSON file or an XML file or an HTML file, where we have data in form of tags. So we need to convert them into a structured form. And the third format is a unstructured form, where the data comes in form of a text file or a doc file or a PDF. So the data has to be extracted, converted into a structured form, and then proceed with the machine learning techniques. Now, there are three main types of machine learning. The first one is called supervised machine learning. Then we have unsupervised machine learning, and then there is reinforced machine learning. Now, in a supervised machine learning, the technique is you know what you are going to predict. So if I say that I have a data set which contains features and it has one value that you're going to predict, which we call as a dependent variable or a y variable. So whenever I have a y value specified in my data, such kind of data is known as a supervised technique. Example could be a classification problem. It could be a binary or a multi-class classification problem. It could be a regression problem that we saw earlier. So all these are examples of supervised learning techniques. In an unsupervised learning technique, there is only a data set which contains features but does not contain any y variable. That is, there is no prediction involved in these techniques. So the data is grouped into something called clusters, and each cluster will have a group of records which are similar. So no two clusters are same, but records within a cluster are similar. Just to give an example, if I'm doing a research on colleges in India, the engineering colleges. So I'm going to group them into different clusters. So cluster 1 will have a set of colleges which have similar patterns. Cluster 2 will have a set of colleges which have similar patterns. And cluster 3 will have a set of colleges which have similar patterns. But across clusters, we will see that the records differ. So here the idea is the records are grouped based on similarities. So this is called as an unsupervised learning technique where there is no prediction. So you can look at some real life use cases when you want to segregate customers, market segmentation or customer segmentation. And let's take an example of a bank. Now bank has a new product which it wants to target, and it wants to target only a specific set of customers. Now how will the bank manager know whom to target? Let's say it's a gold card which has a lot of credit limit, and it has lots of other benefits. So whom will the bank manager target? So he'll probably look at those customers who have a good credit score, who have a good bank balance, and maybe some other features like how long has been the customer with this bank. You can think of lots of these features. Now, based on these different parameters, I can cluster them and I can find out which customer or which customers belong to the one that I'm looking at. So target only those customers. Now it helps in two ways. Number one, you need not target the entire set of audience. You don't have to send an email to all the 50, 60, 1 lakh or whatever count you have. So you don't, it saves time. And also when you're doing some campaigns, so it will really bring down the cost. So that is why supervised machine learning is used. Now, apart from that, it is also used in other industry. There is one technique called market basket analysis. Now, in this technique, we see that whenever you go to stores and you want to buy some products, so you see that a lot of things are kept together. For example, bread is kept very close to where the milk is. Then you also find juice there. You also find the eggs there. So a lot of these products are kept next to each other. Now, why is this happening? It is mainly used to improve the customer experience. Okay, you don't want to hunt for a certain product by walking across the aisle and getting this. So these are some techniques of unsupervised where the buying patterns of customers are analyzed, and then they figure out that which products sell very well along with some other products. So combination of products which are sold, so they're always kept together. So here you can see that there is no prediction involved. It is just clustering them so that you have a better shopping experience. Now coming to the third one, it is called as a reinforced machine learning. So in this technique, it is mainly to do with designing. So you take an appropriate action based on if the action is good or bad. So when you make a right choice, you give a reward, and when you make the wrong choice, you take away that reward or give a negative marking. So the learning the optimum behavior in an environment. So that is the objective of a reinforcement learning. Just like you have a game design. So whenever you make the right move, you get rewarded, and when you make a false move, you are punished for that or penalized for that. So these are the three main types of machine learning that we use: supervised technique, unsupervised technique, and reinforcement technique. In this video, we discussed about machine learning, the definition, and we also saw a couple of examples. And we also discussed what are the different types of machine learning, that is supervised, unsupervised, and reinforcement machine learning.